Hello guys, today we are going to develop a machine learning model or a binary, I would say a supervised machine learning model, uh, precisely a binary classifier for credit card fraud detection. This is a very popular problem in machine learning community, right? And Kaggle is a very popular website where you can get free data set to practice your uh, data science knowledge, right? In this Kaggle website, I already have the data set, which is you see credit card fraud detection data set we have here. And what is the problem definition, by the way, right? So the problem definition is based on the transaction and transaction characteristics defined by these features V1, V2, V3, right? We are going to predict whether this transaction is a fraudulent transaction or not. Okay, so you see in my data set here, each row represents one transaction, right? We have you see these features V1, V2, V3, V4, V5, all the way up to V9. I feel we have more columns. I have observed that already. We have up to V28, and then amount of the transaction, and then class. So class is what going to be our target variable for the binary classifier that we are going to develop today. Okay, so a class value you see here is the feature, or here is the target variable, which is class. So a class value of 1 means this transaction is a fraudulent transaction, and a class value of 0 means otherwise. Okay. Okay, so I already sorted in a descending order, so that's why you see all ones, right? If you sort in ascending order, you would be able to see 0 values, right? Like non-fraudulent transactions. Okay. So I downloaded this data already in my machine. Before I go into the data, I would like to tell you that today we are not going to write any Python code or Spark or Java code. We are going to use a no-code solution or no-code automated machine learning platform, Gypsysystem.com, right? This website gives us different options to manipulate and play with our data, including developing machine learning models. I already have an account in this platform, so I can log into my account. Okay. Okay, so let's look at the data that I downloaded in my machine first. Okay, where is, okay, why it is not visible? Let me see the data set. Okay, so this is the data set that I downloaded. Okay, now you see we have all the features V1 up to V28, and then amount. This is another feature, and then class, right? 0 or 1, and the time of the transactions, right? Numeric value. So fortunately, we have all numeric here, right? Let's upload the data in our platform, Gypsysystem.com. What should we do, right? So we see different options in this platform. We have supervised model, unsupervised, data cleaning, host model, NLP, data exploration, financial documentation. The first step of any machine learning model development is data exploration. So let's go there. Let's upload our data. So you see the wheel is spinning. That means the data is uploading in this platform. Okay, it's taking a bit time to upload the data set. I think it's around 50 megabyte. Oh, okay, so we are good here. The data has been uploaded. So we see a snapshot of the data or header of the data here. You see the bottom of my screen. I believe we can delete time column or feature. It doesn't bring any value to the problem or target variable, right? I mean, I feel maybe time is not that important to determine whether a transition is fraudulent or not. Let's delete for now. Okay, so okay, now we are doing data exploration. Let's select the class that is our target variable, and let's hit analyze. It seems it's spinning, doing something. Let's wait a bit and let's see what it can do for us. Okay, I see our analysis is done already. Oh, nice. Okay, so first thing, we have correlation metrics, right? We have class distribution, then we have box plot and feature and class relationship diagrams. We have feature statistics, we have mean, max, median, quantile, Q1, Q2, Q3. And then we have top 20 features. Okay, so like which features are more correlated with our target variable. Okay, let's see if, so this is our class, right? And these are all the values, basically correlation values, right? So if I go all the way down, I see class, we can sort it because this is our target variable. So we would like to know which feature or features are highly correlated with our class. Okay. Unfortunately, no feature seems to be highly correlated, right? You see, the highest is 0.07, right? On the positive correlation side, I mean, you know, the more it is towards 1, the more correlated two variables are, right? But still, I mean, few features are correlate a little bit of correlated. I would say these 4 features, maybe 4 or 5 features, right? V4, V2, V27, V11. Okay, so let's go to our training. Before we go to our training, let's save it. Save this analysis, credit, fraud, data exploration. Okay, and hits the save button. Since successfully saved it, so let's go back. Okay, I see our model, descriptive analysis model has been saved here. Okay, so we can go back to there later, but for now, let's go to our supervised learning model development. Let's upload the data set. Yeah, it's taking a bit time to upload 50 megabyte file. Okay, let's delete the time feature for now. Let's select the class and let's train the model. Okay. Okay. Okay, so we have the options to train a classification and regression model. Definitely we are going to develop a binary classifier here. We can adjust the train test split for model validation purpose, right? So let's start with a decision tree, and you see we can modify the variables here, right? These are the hyperparameters of the decision tree classifier. So let's train it for now. Let's see the results of the training. So you see the model decision tree classifier model has been trained now. So while it is training, okay, I think the training is done. The accuracy seems to be good. F1 score, I am not very happy. You see for one class it is 1, another class is 0.49, right? AUC is good, 0.94. Precision, okay, 0.34 is not good. And recall is good basically for both the classes, 1 and 0.89, right? But the precision was not good. 5-fold cross validation, this is very important, right? Five-fold cross validation for F1 score all around 0.7 to 0.8-ish region, right? I think we have some areas of improvement. I feel we have high class imbalance. Let's go to our descriptive analysis again. And yeah, you see here we have 133, yeah, 133,000 of zeros, while we have only 258 ones. It's very highly high class imbalance here, right? All zeros almost, I mean a few ones here, right? So I know in order to resolve this, we can, I mean, in LightGBM classifier, we have scale positive weight, right? So we can adjust this value based on the ratio of positive and negative classes, right? So let's see what is the ratio. So maybe I can grab a calculator and I can check 133,007 divided by 258, 515. So let's copy it. So we can put 515 here, right? Scale pos weight and train LightGBM classifier. And let's see the value. Yeah, so always remember, if you have high class imbalance in a binary classification problem, you need to adjust the weights in your model that you are training. And different models actually offer weight tuning, like XGboost, LightGBM. Even in random forest, you can tune the positive negative weights. Oh,